Okay, so section 4, we're going to talk about the key math skills for chemistry. And I'm going to take a little bit longer with this video. Maybe, I'll try not to be too long, but I will say this is probably the most important. This is why people struggle with chemistry, in my view, is because it's actually not chemistry that people struggle with. It's the math and the relationships behind it. So I want to take some time with it. Now let's go. First of all, the learning goal is to review math concepts used in chemistry, and it's going to really help us a lot if you're comfortable with these things. And if you're not comfortable with them, we're going to practice them until you like them, and then you'll realize that much of what people think is difficult actually turns out to be not so difficult. So, first key concept or key math skill that we're going to talk about is first one is identifying. Where am I here? Identifying place values, okay? So for any number, we can identify the place value for the digits in that number. And we might look at these two numbers, for example. Here, the 2, in this case, is in the thousands place, right? And the 8 is in the ones place. You see that? And here, the 0, for example, is in the hundreds place, okay? So that may seem a little bit elementary. It's true, you learned this a long time ago, but we do need it. And if you get that mixed up in your analysis of data, you're going to have trouble, okay? So let's do a learning check. What is the place value for the underlined digit in this number, 35.679? Where the underlined digit is, can you see it there? The underlined digit is 7, right? You see that? And can you see this is the tens, ones, tenths, 100ths. Okay, so it's the 100ths place. All right? Okay, so the next key math skill is using positive and negative numbers in calculations. Okay? So a positive number is any number that is greater than 0 and has a positive sign. Oftentimes, the positive sign is understood, and we don't write that down. A negative number, though, is below 0, is less than 0, and we do write that with a negative sign. Okay? So let's look at a couple rules. Number 1, when you have two positive numbers or two negative numbers, and you multiply them or divide them, you're going to get positive, right? So negative times negative, where am I? Negative times negative, right? You see that? Gives a positive. A positive times a positive gives a positive, right? A positive divided by a positive gives a positive, and a negative divided by a negative gives a positive, right? So, so conversely, when you have one negative number, a positive times a negative gives a negative, and a positive times a negative times a positive also gives a negative, right? And look at here. A division problem when you only have one negative is also going to give you a negative. You see that? I realize I'm just circling everything here, but I'm just looking at it as I go. And then up here, you see that? A negative divided by a positive also gives you a negative. So this is also something you learned a long time ago, but we are definitely going to need it. Now, when I'm grading answers, grading papers, I see oftentimes this is not an uncommon mistake. All right? So let's talk about addition and subtraction of positive negatives. When you add two positives, of course, where am I here? When you add two positives, 3 plus 4 is going to give a positive 7. And when you add two negatives, you get a negative number, right? Now, when you add a positive and a negative, what you do is you subtract the smaller one from the bigger one, and you take the sign of the bigger one, okay? Or you could just put this in your calculator. 12, find the plus button, right? Plus button. Find the positive negative button, right? It oftentimes looks like that. 1, I guess I should have written that out. 5, right? Equals, that equals button, and you'll get a negative 3, okay? So I don't think this is not such a common mistake, but it's something I think worth highlighting, all right? So let me skip past this. I'll leave it on the screen for just a second. But this is going to be, if you're doing this with a calculator, doing it carefully, you won't make a mistake. I said if, right? It's real easy to make mistakes with calculators. Okay, so the next key skill then, the next key math skill is calculating percentages, okay? So percentages is you divide the part by the whole and you multiply by 100, okay? So if you have 8 chemistry books and you have 32 books total, 8 divided by 32 times 100 gives 25%, okay? And then going backwards, if a percentage of red balls is 5, that means you have 5 red balls over 100 balls, right? That's what 5% means. And of course, multiplied by 100%. How do you spell 100? 100%. I'm just writing what you have there, okay? So we'll be doing lots of percent. You'll get a lot more chance to practice this, but you may want to put this in your list of things to do, is calculating percentages. Again, we'll have them in our assigned problems. Okay, now equations, the next key skill is solving equations, rearranging equations. Equations can be rearranged to solve for an unknown variable. Well, first of all, put all the like terms on one side. So if you have a positive 8 here, the inverse function of addition is subtraction, so you subtract 8 from both sides, right? So 2x is equal to 6. And then you have a multiplication problem. 2x is a multiplication problem. The inverse function of that is division, so we divide everything by 2, right? You see that? 2's cross off, and we get x is equal to 3. Okay? So it's, I think, going to be super helpful for you to check your answer. If x is equal to 3, let me come back up here. It's down here at the bottom of the page, but let's do it up here too. 2, and here's my x is 3. Plus 8 is equal to 2 times 3 is 6 plus 8 is equal to 14. And yes, okay, sure enough, 14 is 14. All right, so solving equations. Here's another sample problem for that. This looks a little more like what we're going to see in our chemistry textbook. P1V1 is equal to P2V2. Solve the equation for P1. And I see I've got a multiplication problem here. P1 times V1, right, is equal to P2 V2. And so I want to solve for P1. I got to divide everything by V1 because the inverse function of multiplication is addition or is division. So divide everything by V1. My V1s here will cross off, and I'll have P1 is equal to P2 V2 over V1. Okay? All right, and so the last key math skill that we're going to need, oops, where's my draw? Last key math skill is interpreting graphs. Big deal. Okay, a graph represents the relationship between two variables. It contains two perpendicular axes, and we oftentimes call them an x and a y axis. They're really the independent variable and the dependent variable, okay? But we call them x and y axis, or horizontal and vertical axes, okay? So let's go here and look at this graph. So first of all, we'll just step our way through it. First of all, the title is the volume of a balloon versus its temperature, the temperature of the air inside it. Okay, and the x-axis is temperature. I can see that, and the y-axis is volume. I can see that. Okay, and you can see that these points are gonna, if we take the temperature, it looks like what happened was the volume of the balloon. The volume of the balloon was measured as the temperature was increased, and we saw that at 0 degrees Celsius, it was pretty small, right? Almost 22 liters. At 20 degrees Celsius, it was a little bit bigger. You see 24, right? And we see it looks like at 40 degrees, it was measured to be, oh, I can't see what that is. I guess 25 and a half maybe, right? And what's this right here? It looks like that's 70 degrees Celsius. It looks like it was just over 28, maybe 28.2, right? You see that? Okay. And so graphs are super powerful because they give us the ability to make predictions. If I were to say to you, predict what is going to be the volume at, let's say, 65 degrees. So what you would do is you would come here, if that's 70, here's 65, you would come up here, right? You see what I'm doing? Aha, it's probably going to be right there, okay? So it looks like the volume is going to be, and what is that? About 27.7 maybe? Yeah. 27.7 liters, right? That is my prediction for the volume at 65 degrees Celsius, okay? So that's what graphs are good for, and we will work with graphs over and over and over again. So again, the key math skills are, number 1, identifying place values. Number 2, using positive and negatives in calculations. Number 3, calculating percents. Number 4, solving equations. And number 5, interpreting graphs. All right, we'll get lots of practice with these this semester.